Welcome back to our lecture, to our course on industrial organization. Last week I gave you an introduction to I/O and also gave you a brief overview about the history of I/O and how this field developed today. And I also gave you a small refresher on one of the two benchmark models we consider that would be perfect competition. Today we move on to look at the other benchmark, which would be pure monopoly, and with which you also should be rather familiar in terms of your that you did it in terms of your undergraduate study. Okay, so we will start now with the monopoly situation. And what was interesting, I also told you something about minimum efficient scale or most efficient scale, and we saw how that is related to the market structure. And of course, if we have a very large minimum efficient scale compared to, say, the size of the market, that is demand, we might actually end up with a monopoly situation. So if we have very high fixed costs compared to the market size, we might end up with a monopoly, and that's exactly what we are going to do in the next chapter, in chapter C, where we talk about technology and cost functions. But today we just want to briefly look into pure monopoly and how that looks like. You certainly hopefully know all the formalities we need here, and I just want to start with, of course, the standard assumption we have. If we have a monopoly, we have a single supplier. This single supplier faces a negatively sloped demand function, and what we assume here is that there is no potential market entry, so there is no threat of entry. Some of you who already took the economics of regulation course know that even potential market entry might play an important role if we have so-called contestable markets, but here we assume that we have no potential entry. And so we need some notation in order to look into that. We denote Q as a quantity, we denote C as cost, where costs typically depend on the output, and we look into the inverse demand function, which is also the demand curve, where P is just a function of Q, and we denote here, I use the capital pi with pi the profit, and again the profit depends on Q, even though we of course could also write it in terms of P, because now of course our monopolist is a price setter rather than a price taker, and of course it doesn't matter whether the monopolist sets the price or the quantity, because of course if she determines one variable, it's the demand function directly determines the other. We have an assumption on marginal cost and on the slope of the demand curve. Marginal costs are non-negative. Suppose we have software or some digital products which will have marginal cost of 0, and the slope of the demand curve which is non-positive, so demand is downward slope. I think that should be enough, and that's rather standard. The objective function is, as always, that we simply assume profit maximization. We abstract from any agency problems and so on we might have with the separation of ownership and control, which we dealt briefly with in the introduction in terms of these principal agent problems or transaction cost theory. And then we simply maximize profit by where profit is just the difference between revenue and cost, and we could also differentiate with respect to price. That would just mean that we write all these terms in terms of prices, but here we, as usual, do it in terms of quantities, derive the first order condition. Of course, we could also just write d pi dq, which is then just the same expression we have below here. And here what we have here is nothing else than marginal revenue. The important point about marginal revenue is that it's smaller than the price here compared to perfect competition, as we have also to take into account what is called the so-called inframarginal effects. we sell to the marginal consumer at a price which is this one given here, but we would also have sold the previous units already at a higher price, and we have to reduce that due to this price change, or to this quantity change, we have to say. Okay, if you want to sell more, you have to reduce the price, and that affects the so-called inframarginal units. This is this second part here. Okay, and in the optimum, it's equal to marginal cost. We can also put that in terms of, or we can use the price elasticity of demand in order to set it up, the first order condition and the optimality condition, with the help of the price elasticity of demand. Price elasticity of demand is simply the percentage change the percentage change in quantity, which is triggered by a 1% change in prices. Okay, that's how we always would write it. Okay, so I think I didn't do it before, so we might also write it as dq over q divided by dp over p. So here you see then in more directly the percentage changes. Even though this is a bit of hand waving, we could then use just a del, which is with del I mean this Greek letter here, which just accounts for discrete changes. Okay, but here that should be sufficient. Now, if we and again I probably confuse you with all my drawings here, but the point is here what we see, and I just erase it here. P prime of Q, of course, is nothing else in terms of notation than dP dQ. Okay, is dP dQ, and so you see here you have dQ dP, and this is just 1 over this, and it's straightforward to substitute that here. That should be clear. Okay, so of course I could write it down here. So what you would do is just to write it as factor out P, you get 1 plus Q over P times what do we have, dP over dQ. Okay, that's what we have here on this left hand side. Yeah, but this is nothing else than this is a 1 up here. Okay, this is this one here, and this is nothing else than minus here. Again, you see the minus. We always define the demand elasticity in absolute terms. We always know if you increase the price, demand will go down. Okay, and so this is nothing else than minus 1 over epsilon. And now I can erase it because in YouTube we will have it later on, and I have some more lines of text here. Okay, that's how you derive it. And what is interesting here is, of course, as you see, epsilon has to be larger than 1. Otherwise, if it's 1/2, for instance, this expression would be negative. You would get 1 minus 2. And of course, that would mean for positive marginal cost, you would get a negative price, which is nonsense. But of course, what would happen if actually demand is non-elastic or inelastic? That might happen. For instance, your demand for electricity will be rather inelastic. The point here simply is then we get up here again to our derivative of the profit function. If epsilon is smaller than 1, actually this expression, the marginal revenue, will be negative. Okay, that's exactly what this is. Nothing else than the marginal revenue. This expression here with the elasticity, marginal revenue will be negative, but that means both the marginal revenue and the marginal cost are negative. So what we get here is that d pi dq is smaller than 0. What does this tell you? If you increase the quantity, your profit goes down. So how do you increase your profit? You reduce quantity. Actually, you would reduce quantity as much as possible, in the end sending only 1 unit as a very high price. Okay, that's what would be optimal. And that is also the point why we have, if we have an industry where we have a monopoly and where the elasticity of demand is inelastic, we typically have a regulation or something like that, because firms would have an incentive to charge very, very high prices. Okay. Hopefully that was clear. What we also use very often are some what we call measures of market power, like the learner index. The learner index gives you the so-called price cost margin. You see here in the numerator, it's just operating profit per unit. And in a denominator, you just normalized by price, and this is exactly equal to 1 over epsilon. So that's rather interesting, because the price elasticity, the inverse of the price elasticity, gives you the market power a monopolist has. And of course, you see directly that this market power crucially depends on demand elasticity. If demand elasticity is say 2, you have 50% of your price is operating profit. If demand elasticity is 150 or 100, it's only 100. So the more elastic demand is, the less monopoly power you actually have, even though you're a monopolist. That will be a discussion later on when we consider whether closed substitutes exist or something like that. Similar, we can define or have a very similar expression where we just normalize by the marginal cost, and then we would get the markup factor. If demand elasticity, for instance, is 2, your markup factor would be 100%. So if you have marginal cost of 10, you know your price will be 20. Okay, that's what it is. I think that's what I wanted to tell you about this, and hopefully this is what is clear to you anyway from your undergraduate studies, and that's only a refresher. Anyway, we will have, I think, a problem in the assignment on that. Okay, yeah, now, of course, you always know we can illustrate our results or our monopoly problem in terms of a diagram, and here I did my best in terms of simulating or animating this diagram. Here you see the 2 axes, which give you then on the abscissa the quantity, on the ordinate the price. Here you have a demand curve. Here you have then the marginal revenue curve, and here we, for simplicity, assume that marginal costs are constant. Is always the same, and immediately we get a price equal marginal cost, marginal revenue equal marginal cost. Here this intersection gives you the optimal quantity, okay? And going up to the demand curve, we get the optimal price, okay? And the nice thing about a monopoly is here, this yellow area. This yellow area is similar to the profit, but it's actually what is called producer surplus. What is the difference between profit and producer surplus? It's a fixed cost, okay? The producer surplus is profit plus fixed cost, or in order to get the profit from the producer surplus, you have to subtract fixed cost here, because these fixed costs are not covered in this diagram. What you also see, and we will get back to that, is that price is higher than marginal cost. This is an important result, and that's what will lead to the so-called deadweight loss to inefficiency here. And that's what we are going to turn next to, namely efficiency and welfare issues. So what is efficiency? All of you hopefully know this Pareto efficiency definition here. A situation is Pareto efficient if no reallocation of the available resources is possible that makes one economic agent better off without making some other economic agent worse off. This is, in a sense, a general equilibrium definition we use. If we have something like the Edgeworth box or something like that in microeconomics. What we typically look at is a slightly different measure of well-being, because, of course, with this Pareto criterion, we cannot compare situations where some people or some agents win and other agents lose, But that's typical in markets if we have some changes, that some agents win and some agents use. We therefore use a different measure of welfare, in a sense a monetary measure, and our two measures are here consumer surplus and producer surplus. Okay, what is consumer surplus? It's just the difference between the willingness to pay for a certain unit of the product and what you have actually to pay. And the total consumer surplus, you will then see that in the diagram, is just the difference between the demand curve and your expenditure. Okay, and aggregate consumer surplus is a sum over all units consumed and all consumers. Producer surplus is just what you saw, just the difference between the amount producer receives, that is his revenue from the sale of a unit, and actually for one unit it's a price, of course, and the amount that which unit costs to produce. And of course, aggregate producer surplus is a sum over all units, and what is important, and all units and all producers, but what is important and is our typical welfare measure is total surplus. There's consumer surplus plus producer surplus. Students who already took the economics of regulation course will remember that regulators typically have a different welfare measure. They somehow put a weight here like alpha on producer surplus, and alpha is something which is between 0 and 1. So they account more for consumer surplus than for producer surplus. Okay, but here we typically assume that we have a total surplus welfare measure. Yeah, now I loosely define consumer surplus as it's important, and we will use it at some length. I spent 2 more slides or 3 more slides on that, also introducing what is called the partial equilibrium approach or model. First of all, consumer surplus. Of course, the starting point is always demand, consumer demand. We have the demand function as well as the inverse demand function. So demand function is always quantity as a function of price, whereas the demand curve or inverse demand function, so the inverse demand function is also called demand curve. Demand curve is just price as a function of quantity, which is just the inverse. And consumer surplus then can be calculated given you have some price P0, which is the current price, and some cutoff price P upper bar, that would be relevant for linear demand, can be calculated in 2 ways. Of course, if we in terms of our diagram, if we have here something like this price P0, this would be the cutoff price P upper bar, and of course our consumer surplus would be just this area. And we can, of course, if we want to formally derive or calculate an area, it's always an integral. Of course, here it's just a triangle with linear demand. So you wouldn't start to integrate, but just use the simple formula for a triangle. But here what you see is you can integrate over the demand function here, okay, from P0 up to P upper bar. And that's if you integrate here horizontally over this area, okay? So here you have, actually, if you do it horizontally, you get the inverse here, which is the demand function then, and you would integrate like this, or you might also do it horizontally by using the demand curve. Here you see this is just the area below the demand curve. This thing here is the area below the demand curve. This is actually what is called GCS, gross consumer surplus. Okay, and of course, in order to get what is called net consumer surplus, or what we will refer to as consumer surplus, in order to get this triangle up here, you have to subtract your expenditure, and of course, this would be then Q of P0, the respective price. But that's nothing new. You will have to calculate it anyway in very many of the problems, but this is just really a minor point. Okay, yeah, and I already told you we will use what is called a partial equilibrium model, and there's something like a standard, or if it's a standard model which is usually applied, we might also call it canonical partial equilibrium model. I have taken this from Javier Vives' textbook, Oligopoly Pricing, Old Ideas and New Tools. So what we typically do in I/O is that we employ partial equilibrium models. So what does that mean? We look only into a specific market and abstract from what happens in other markets. We just use a numeraire. You will see that in a minute what this means. Actually, we only are interested in a certain product or in a certain good. Even though that good might be a differentiated product like car, we don't account for other products, and we don't account for labor markets or something like that. That's different, for instance, from trade theory, which typically has two good models, and also takes into account like general equilibrium effects. We only look into a single model, and what we do then is just looking at the optimization problem of what is called a representative consumer. I will tell you in a second what this means in this context. And what is very important is that this consumer has quasi-linear utility. What does this mean? It looks like this here. So W would be your upper utility in a sense, which is made up of Q0, and Q0 is nothing else as the numeraire good, which has the price of 1. So this is just your money, okay? And here our Q, which is actually a vector or could be a vector, this is just the good which we are interested in. This might be, I don't know, sugar. If you are interested in a sugar market, it might also be, and then it would be a scalar, a single product. But if it's cars, it might be and different products, just as here, and different cars. Of course, each individual consumer will often only consume one car or one unit of a car. But if you look at a representative consumer, they are just made up of might be made up of heterogeneous consumers, and when we end up with different demands for cars, or cars for demands for different cars. Yeah, and what we assume here, of course, that's why this Q0 enters in a linear way. That's why these utilities called quasi-linear. And here we have this sub-utility function U of Q, okay? This is a standard utility function which is increasing and concave, which has the standard properties. And yeah, that's how it is, okay? Yeah. Okay. And final point, of course, our consumer has to take into account the budget constraint. We have a given income I, and we spend this income on the numeraire and on our product which we are interested in. And typically we will assume that this income I is large, in the sense that in equilibrium Q0, that is a consumption of the numeraire, is positive. That's something you will address in I think in problem 1 of the assignment 1. Okay. Where you have to calculate how high has I, the income, to be at least, so that our consumer consumes still the numeraire. Otherwise, you get a corner solution. Yeah, what you have here, of course, is then a standard optimization problem. You might set up that in terms of a Lagrangian, even though it's much simpler here, because you simply, and I think I do that here, you simply could just substitute here the Q0. You put the P and Q on the other hand with the minus, and you substitute here, so you get a unrestricted optimization problem without a constraint. So it's rather simple. But what is also interesting to see, if you set up a Lagrangian here, Lagrangian with W minus lambda, and here then the constraint Q0 plus PQ minus I. Here I just assume that it's not a vector here, but a single single product minus I, you see that if you take the derivative of the Lagrangian with respect to I, you simply get lambda. Okay? This is because you don't see it directly because the W is simply Q0 minus lambda Q0. And if you take the derivative, okay, this is a shame, I'm too quick. First of all, if you take the derivative with respect, you see, actually I should play around and should use OneNote here. Might be more straightforward if I do the notes here. Okay, what we have here is dl dq0. Okay, and that's simply, if I don't see the slides right now, but this was then simply, we had Q0, it would be simply 1. Okay, the price of the numeraire is 1 minus lambda, and then we have again Q0. So this would be our first our condition, optimality condition with respect to Q0. And as the optimality requires that this is 0, we obtain, of course, that lambda is equal to 1. Okay, and the other point was that the Lagrangian, taking the derivative with respect to income, you see that this was 1. Oh, I should write it in the English way, the 1, and you see what in a sense the shadow price, or actually it's not a shadow price, it's a marginal utility of income, which is 1. 1 more unit of income gives you just the utility of 1. Okay, hopefully that was somehow clearer, as I tried not to confuse you completely with just crowding my slide. Okay, so hopefully it's clear. The Lagrange multiplier is equal to 1. And this is also what is called the marginal utility of income. That's what's also stated in more detail in the notes. Okay, and now if we have here this optimization problem, as I is just a constant, which you typically, which is exogenous here, you know that the maximum value of Q here is independent of your I, which is very important. Okay, your optimal decision on a car or on sugar, on your sugar consumption, depends on the price, but not on your income. And it's the same as the maximizing argument of this subutility function. And this subutility function is actually nothing else than what we call the consumer surplus. Okay, this would be nothing else than the consumer surplus. This is exactly what we get here. And consumer surplus then just tells you what you get in additional surplus or in additional utility from the existence of that specific market with this product Q. Okay, that's what we have here. Oh, yeah, and here I'm done. And the point is here, again, you will have a problem in the assignment where you just calculate this utility function and so on, and the optimal demand function for some standard linear demand curve. Okay, so in the notes I have this example that in the easiest case U could be equal to A times Q minus 1/2 times B over Q squared. And if you take the derivative here with respect to Q, you simply get A minus BQ is equal to P, which is nothing else than our standard linear demand function. Okay? This is directly what you would get from maximizing a consumer surplus here. Okay, and that's very similar to what we do in the assignment. Yeah, some more general properties this function here. Again, what we did is we maximize this expression I just showed you. If we maximize our linear, this is called the linear quadratic utility function, okay? Because it's the first term is linear, the second is quadratic. We just get that a price is equal to A minus BQ. And we have some further features of that model. First of all, that was exactly what I just derived. So you get directly from the first order condition the demand curve, okay, the inverse demand function. And another property is this symmetric cross effects property. So if you take a second derivative here, if you take the derivative of dpi, so if you have several products, several cars, if you have if you have daytime consumption of electricity and nighttime consumption of electricity, for instance, and you take the derivative, the cross derivative, this is nothing else from here, okay? From here, nothing else than, oh, again, I have to work on my illustrations here. It's nothing else than the second derivative of the utility function, then with respect to Qj and to Qi, okay? And if you here take the second derivative, is exactly, and I don't write it here because you will be confused anyway, you just would switch these two indices and you get exactly the same, okay? It doesn't matter in which order you take these partial derivatives. And that's why you get this equality sign here. And that means that the effect is the same. If you change the price of the one product or if you change the quantity of the one product on the price of the one other product, and now it gets complicated. Or if you change the price of the other product and then change the quantity, how the quantity of the other product changes. Okay? I don't know whether you're convinced with that, but it should be straightforward. You can just calculate it. And of course, it doesn't matter if you have your simple linear demand function. It will matter if you have another frequent example where we look into, if I could just, I don't know whether we have it in the assignment. Just look whether we already have this in our assignment, the linear quadratic version. No, it will be later in the assignment, where you have U is something like A1 Q1 minus B1 Q1 squared over 2 minus plus A2 for Q2 minus B2 Q2 squared over 2 minus something sigma Q1 Q2, which would be something where we have a linear quadratic utility function with two products where it's a differentiated product. Again, the inverse demand function would be very straightforward and simple, because inverse demand function for P1 would simply be here just A1 minus B1 Q1 minus sigma Q2. Okay, so here the price of product 1 depends on how much of product 2 you consume. Okay, that's another kind of utility and demand function, or inverse demand function we are going to use. You don't need it right now, but it just wanted to give you a preview. And again, I probably would have better put it on the OneNote. Okay, yeah. So hopefully these, and now the cross effects are interesting. I discussed that in some length at EOR, but don't spend more time right now here. And finally here, what you get is that these derivatives of the inverse demand function of price with respect to Q must be negative. This is just a consequence of the optimality or of the condition for a maximum. If you have you know the condition for a maximum if you have a single variable is that the second derivative or the second order condition is that it's negative. Okay, if you have more variables, you have not only a single second condition, but you have several of them, and if you take the several of them, you have a so-called definite Hessian matrix, and these Hessian matrix must be, you have a Hessian matrix, and which must be negative semi-definite or negative definite here, and that just means that these values must be positive. I don't spend more time, and this is a technical detail you will need here. Okay, again I have to erase here. So I promised you that we will have even more equations and formulas, so it starts to get reality. Okay, but here, as you will see from the assignment or from the problem, it's rather straightforward. You will have given certain kind of demand functions or certain kind of utility functions, and it will be straightforward. So then once we have set up this problem, of course, we can solve for the optimal Q. That's what we did on the previous slide already. And once we've solved for the optimal Q, of course, the optimal Q will always be a function of P, because for our consumer, the prices are given. We can substitute that in the consumer surplus, which we previously had, where consumer surplus was simply U of Q minus P of Q. If we substitute then our demand functions, which we derive from our maximization problem, we get a so-called maximum value function, which is here also the same as the indirect utility function. So we directly know, if we have this condition, what the consumer surplus for given prices is. And of course, this depends on both our utility we get from these prices, and of course the prices determine the quantity determine the utility, and here we have of course then a price and a quantity again, and this has a nice character or property which you can derive from the envelope, so-called envelope theorem. What you see here, if you take the derivative of this maximum value function with respect to one price, you get this expression. Okay, how do you get this expression? Now, dp du or u doesn't directly depend on p; it depends on q. So you first take a derivative of u with respect to q, and then you take then you apply what is called chain rule to get dq over dp. Okay, and here it's the same. You take the derivative in the second expression with respect to q, and then again you take the derivative of apply chain rule of q with respect to p. And then you get also this here. So I could have written it differently. If you take the derivative, you would get first. If you would, I already factored it out. That's a point here. So you just can put that here, and then would that be on a second spot, because that's what you get here. Du, dq. Just write it down here. But again, you get du dq j times dq j dpi. Okay, that would be, and then you also get this. If you take the derivative with respect to pi, you get di here, and you get then, if you take the derivative with respect to d, which would be just this, you get pj times dqj over dpi. And the interesting point here is, again it's crowded, the interesting point here is that you know what this is. This is actually zero, okay? because that's nothing else than our optimality condition from up here. This is 0, and what we get if we marginally increase the price, we get only the so-called direct effect. And what happens to your consumer surplus if you marginally increase the price? Yeah, your utility goes down, and by how much? Yeah, by just how much you consume. So if you consume 1,000 minutes of telephone calls each month, and your price per call goes up by 1 cent, yeah, your utility decreases by 1,000 times this 1 cent. Okay, that's what we get. So yeah. That's important, and that's a property we very often use. And finally, that's what I already told you. With quasi-linear utility, you do not have any income effects, okay? Because income doesn't enter your demand. And what that means becomes clear, hopefully, on this next slide, because as you don't have an income effect, the distribution of income does not matter for aggregate demand. So you just can aggregate each individual demand. So here you have the consumer surplus actually here I do not aggregate the demand function, because you directly get the demand function as you saw by taking the derivative with respect. Oh, actually, did I make that clear? So you get here, what you see is you directly get the demand function by taking the derivative with respect to the respective price of the consumer surplus, okay? And so once you have the consumer surplus function, of course, you always have to also have the demand function. And now the point is here, consumer surplus, aggregate consumer surplus, and therefore also aggregate welfare, if you have here plus the income, is nothing else than the sum of the individual consumer surpluses plus the sum of the individual incomes, okay? And income distribution doesn't matter. Yeah, why? I have one caveat. Income distribution doesn't matter as long as income is so high that every consumer, or that income of every consumer is so high that every consumer consumes the numeraire, okay? And of course, this is an important assumption. And we will get back to that once we look into vertical product differentiation, quality differentiation, because you will see in some countries with a rather unequal distribution of income, you see very different cars or a very different car distribution than in countries which have a more equal distribution of income. Okay? Yeah, my favorite subject is always Russia versus or example is Russia versus Denmark, but I will get back to that later. I just want to draw your attention that this is a rather specific and strong assumption, and also restrictive one. Okay, and very often we also have additively separable utility function across products. What does this mean? It means that the cross effects, the cross price effects are 0. What does it mean? And that's even more important in economics of regulation. It means that no cross price effect if the price for daytime or for local calls goes up, it doesn't have an effect on the number or on your consumption of far distance calls. Okay, however, in many of our cases, we will have this price effect, because if the price of a BMW goes up, this will affect the demand for Mercedes or for Daimler cars. Okay, even though these are differentiated cars, there will be a cross price effect. Okay, so this would be the case in our previous example, which I wrote down, if you wouldn't have this sigma parameter. Okay, I gave you this if sigma were 0 in our simple example, and we will have later on examples in the assignments. Okay, and if you have these additively separable utility functions, okay, the consumer surplus is simply the sum of the area under independent demand functions, and you don't have any problems with path dependent and so on. This is more important in economics of regulation. There's a long discussion on that. We typically just abstract from these problems. Okay, yeah, now hopefully I didn't confuse you too much. So this is some special properties of these canonical partial equilibrium model. The most important part is actually that, of course, we use typically consumer surplus. We can easily use consumer surplus if we have these kind of quasi-linear utility functions, which give us demand functions which are independent of income. Okay, and of course we have to, if we model or if we analyze a certain market, we have to take into account or think about whether this is too restrictive an assumption. Okay, perhaps I make a short break here before I move on with our properties of the market equilibrium and talk about efficiency, because there might well be questions about that. Okay, the properties of market equilibrium under perfect competition. After going through the details of this canonical partial equilibrium model, we look into our efficiency properties once we really have derived what consumer surplus is and what you already know from your undergraduate studies, and what we already showed or showed yesterday in once we looked into perfect competition. We saw that production is at minimum or most efficient scale. In the LRE is here the long run equilibrium, and long run equilibrium. Okay, long run equilibrium. And that means, as you saw, we are at the minimum of the U-shaped average cost curve. That means that total social cost of production is minimized, and that means that we have technical efficiency, or as it's also called sometimes, productive efficiency. Okay, productive efficiency. We produce at the minimum, at the most efficient cost level. And we also have allocative efficiency. What does that mean? Yeah, each consumer who is willing to pay the marginal social cost of the production, which are also the marginal cost of our firms, obtains the good, and that means we maximize total surplus. And that can also be illustrated here by means of our diagram. Here I already have the deadweight loss of the monopoly, but under perfect competition, you know, price would be equal to marginal cost. Okay, and so you would get the whole triangle here as consumer surplus. Firm's profit would be abstract here for a minute from the existence of fixed costs. Otherwise, we run into trouble with this kind of cost function. And what you see here is everyone who has a willingness to pay, that is where the demand function is above marginal cost, here gets the product. Those who have a marginal cost or a willingness to pay lower don't get it. Okay. Now, what is the difference here with respect to the monopoly? We already derived that. We saw that the monopoly sells at a price which is higher, and this has two effects. The first of all is the monopolist makes a profit or a producer surplus here. And what does that mean? Will consumers like that? Probably not, okay, because this is a redistribution. This is not a loss in terms of total surplus, but this is a redistribution from consumers to the firm. But we also have a loss in total surplus, which is this deadweight triangle, okay? This is a so-called deadweight loss. And where does it come from? Yeah, it simply comes from the fact that there are consumers here in the area of the triangle who are willing to pay more than the marginal cost, but they don't get it, the product. Why does the monopolist not sell it to them? That's a problem, because otherwise she would have to reduce the price, and that would reduce profit. Okay, so here you get the standard and well-known deadweight loss. And that's a bad thing about monopoly. Okay, and that's what's also stated on this slide. Why can a monopolist not appropriate the deadweight loss? Of course, the monopolist would rather like to have this triangle. The point is, if he wants or she wants to sell these further units of output, this would require a reduction in price. Of course, this assumes that no price discrimination is possible. Later on, I don't know, in chapter D or so, we will look into cases where firms can discriminate among consumers, okay, and sell their output at different prices, and what the result will be there. You will see the result might be rather different. But if price discrimination is not possible, we get this kind of deadweight loss. Okay. Yeah, and of course, why does a monopolist then not maximize total surplus, but her own surplus, as she's interested only in her profit and not in consumer surplus? Okay. Of course, also in this monopoly, that's what you see, the consumers get some social surplus. And here is where we are, for instance, in economics of innovation. Of course, if that's a new product, if this is a new iPhone in 2007, even though Apple charges a monopoly price, it's better that this new product is brought to the market because consumer surplus earn at least some consumer surplus here. Okay? Or consumers earn at least or have at least some consumer surplus. Okay? So consumers have some surplus. And what is the reason here, or what does this mean? That the monopolist undersupplies relative to the competitive outcome. We get what is called allocative inefficiency. Some consumers have a willingness to pay greater than the social cost of production, but are not served by the monopoly. Okay? And of course, I already mentioned this yellow area, this yellow rectangle. We have distributional concerns. That's what's currently a huge debate. We have these huge internet platforms which make huge profits, okay? And here the point is that due to market power, you have the shift of surplus from consumers to these monopolists to the firm owners. Okay? That's what we have here. You might wonder how that is possible if you don't pay anything for Facebook or Google. For instance, the English Competition and Market Authority assumes or estimates that this market power just leads to the fact that advertisers have to pay higher prices for their advertisements on these platforms, and this then leads to higher prices for final customers. Okay, what is the primary problem? The monopolist is large relative to the market. And I again want to draw a picture, but now I'm really going first to OneNote in order not to make it not too confusing. So what does it mean that monopolist is large compared to the market? Unfortunately, my standard example is Bayern Munich and the Allianz Arena. Bayern Munich is the monopolist in terms of tickets for the games against some other firms, okay? And so what you see here in terms of Bayern München, if audience is allowed, okay, if fans are allowed in the Allianz Arena. So here what you have, how does the cost function of Bayern Munich look like for the Allianz Arena? Actually here you have an output of 75,000, okay, which is actually the capacity of the Allianz Arena. What will be how will the marginal cost look like? Naja, can you put 75,001 consumer or spectator in? No. Okay, you have here some capacity constraints, some very strict one. Actually, you are not allowed for fire and for fire protection and whatever reason, so you cannot put more. Marginal cost apart from that, given that the Allianz Arena is pretty much fixed cost, okay, will be very low. Okay, so here you see you have very low marginal cost. Of course, here's the price. And now how does demand look like? actually demand will be very far up here, okay? And so the problem is, or the point is, marginal revenue will also be up here. So the point is, in equilibrium, Allianz Arena will always be sold out, and given that marginal revenue is above marginal cost, Bayern Munich would always like to sell more tickets. So it will always be sold out, and the price, of course, will always be just a price where the demand curve just here intersects or meets the capacity constraint. Okay, this would be the monopoly price, because Bayern Munich is a monopolist, but this would be also the price under perfect competition. Okay? Because this is the only market clearing price here. Capacity is fully utilized, so you don't have a problem. You would have a problem if capacity would be free, or probably you wouldn't have a problem with Bayern Munich with a capacity of 350,000, but at least with Eintracht Frankfurt, they are always not sold out. Okay? So the point is, if capacity of the monopolist is, or if the monopolist really is then not so large compared to the market here, you don't have a monopoly problem. You don't have a deadweight loss. Hopefully this was somehow clear, okay? This is the size of the market. Again, we will also see a related point in our next topic, where we go to the question whether a monopolist's market power is restricted in the case of durable goods. Okay, who is Apple's most important competitor? That's what I already told you last week or yesterday. It might be that it's Apple on its own. Okay, it doesn't work so nice here with iPhone 12 versus iPhone 10, but it works well for the iPad, and I try to make this point right now and to explain it to you right now what I mean. The point is that durability of a product, so iPhone typically lasts for more than 1 year, okay, say 5 or probably not more, but at least it's a durable product, and durability may reduce the monopolist's ability to set a price above the current level or above the competitive price. We could also discuss this topic in terms of what is called intertemporal price discrimination, and that's where this Apple topic comes in. Okay, what is the idea? Suppose or when Apple brought the iPad into the market, what did they do? I don't know when it was and whether you were, well, it was about 5 or 6 years ago, is that? Or probably even 8. What they did is they sold it, the first units, at a very high price. But later on, they reduced the price. Okay? The point is, if you have a durable product and if you have consumers with a different willingness to pay, you have people who are willing to pay a lot for an iPad. And you have some people who say, okay, if it's cheap enough, I also buy an iPad. What might be an interesting business strategy? The business strategy might be, okay, I sell it in the first year at a very high price to those who are really enthusiastic about my product, and then I reduce the price in order to sell more units and in also to get these people with a lower willingness to pay to buy my product. Okay, that's the idea here. Hopefully it's somehow clear. What is the problem here? Rational consumers might take that into account and wait. They know, okay, today it's very expensive because you want to rip off the high value consumers, but tomorrow you will reduce the price. And I just want to wait, okay? I wait, and that means that Apple if you have if you can expect that the reduce the price, they will have no sales in the first period if they charge a very high price. So in order to have sales, they have to reduce the price. And in the limit, actually, as everyone knows, in the end, you will sell to everyone who has a willingness to pay off price above marginal product. They all will wait, and you know they will wait. Therefore, you better sell it in the very first period. And that's actually a cost conjecture. That due to the fact that you have durability, you really make you sell your own product or your own most important competitor in dynamic terms. Okay, complicated. That's why I try to explain it to you by means of a simple example with only 2 periods and only 2 types of consumers and 2 units of a durable good. Okay. Then we get back to that if it's not clear. So the point is, consider we have 2 periods, so we need a dynamic problem. And we have a monopolist with 2 units of a durable good. These 2 units are already produced. Okay, so the marginal costs are 0, they are sunk. Okay, you have 2 units of this durable good. And now you have consumers. One consumer values this product at $50 per period. The other at $30 per period. And you have some discount factor. R might, the interest rate here might be, the small r might be 0, then discount factor would be 1. If it's 10 or if it's 100%, the discount factor would be 1/2. What does that mean? I think I have that here. Buying in the first period, if you buy it in the first period, you have your iPad for 2 periods, and it's worthwhile then 1 plus R times your valuation. So if R, the discount factor would be 1, the value or the maximum willingness to pay of this high value consumer would be simply 100. Okay? And if R, small r would be 100%, so it's 1/2, it would be 75. Okay? That's what it is. That's you take into account what it's worth today and what it's worth tomorrow. Hopefully this is clear. Okay, now what can you do? You can either sell 2 units in the first period, so only 2 consumers, you have 2 units. Okay, you will see this makes still an interesting problem. You can either sell 2 units in the first period. You can sell 1 unit in the first period. Of course, you would sell it in the first period to the high value consumer and in the second period to the low value consumers. And you can sell 2 units in the second unit. You will always sell, due to these assumptions, you will always sell 2 units in the second period. Okay, because in the second period, remember, you have marginal cost of 0. You have it already available. If you sell 2 units, you have a revenue of 2 times 30, which is 60, which is higher than 50. Okay, so the price in the second period will always be 30, irrespective if you have only 1 consumer in the second period. Of course, the price will be 30. If you have 2 consumers in the second period, the price will always also be 30. Now, yeah, that's what I just explained to you. Now, what happens in the first period? So, at which price can you sell to these high-value consumers? Of course, you would like to to extract all surplus from this consumer. So, sell your iPad really at a very high price to these high-value consumers. And what is the highest possible price? It would be just this 50 times the dynamic utility, so this would be 1 plus R. But would this guy buy this iPad? Unfortunately, our consumer knows in the next period the price will be 30 anyway. Okay, it's a rational consumer. But if I buy right now at this price of 1 plus R times 50, my consumer surplus is 0. Okay. If I wait, my consumer surplus is 50 minus R and I have to multiply it not by 1 plus R, but just by R, because I don't get any utility in the first period, but it's positive. Okay, so I will wait, and that's a problem of Apple here. Okay, I will wait if I expect the price to go down, and of course, then Apple still knows that this is not a good idea. So what it can do here is just to reduce the price in the first period. And now we are just looking for a situation where the consumer, the high value consumer, is indifferent between buying in the first period and buying in the second period. So of course, you could buy as a firm to both consumers at 1 plus R times 30. And now, if you want to buy to sell only to the high value consumers, you can increase this a little bit, this epsilon. So this would be what you charge the high value consumer in addition, if you want to sell 1 unit in the first period and 1 unit in the second period. And what you have to take into account is the consumer surplus of the high value producers. With a price of 1 plus R times 30 plus epsilon, consumer surplus would be simply 1 plus R times 20 minus epsilon. You just get this from subtracting this expression here from the price from here, from the willingness to pay. Okay, and of course, you have to solve for epsilon, if you can see it, in a way so that this consumer surplus is identical to the consumer surplus you get from waiting, which would be just this: the price will be 30, your willingness to pay is 50, and you get it only 1 period, and this is the second period, that's why you have to discount. And if you solve then for epsilon, you get that epsilon must be at most 20 over 1 plus R. Okay? This is straightforward, and I added a line here so that it's clearer. So the price at which the high value consumer is indifferent between buying in the first or buying in the second period is exactly this here. With this price, the consumer would be willing to buy in the first period because her utility is the same irrespective of whether she buys in the first or in the second period. Okay? And now we can look what happens. What the situation is like. Okay, what is the profit if I sell 1 good in the first period and 1 good in the second period? What is my profit? My profit will be this. That was just the price I get from the high value consumers. That's the price I get from the low value consumer. Okay, and that's my and this is then just gives you some 50 plus 60 R. So here you have the 50 times 1, and then you get this expression. Okay? And of course, we have to compare that with the situation in which I sell to both consumers in the first period. At of course, then I have to sell it at a price of 1 plus R times 30. But what you see immediately, this is 60 plus 60R, and 60 plus 60R is larger than 50 plus 60R. So what does that mean? I sell to both consumers in the very first period. Both are sold. Okay? And that's very similar to what we just had in our Allianz Arena example. We don't restrict output. Okay? And the market is efficient, and there is no deadweight loss. This only becomes clear if I show you another example. Of course, this is, I use tricks here, not I, but Pepper Richard Norman, because I deliberately, and they deliberately chose these 50 and 30. Just assume for a minute that it's not the low value consumer has a willingness to pay not of 30, but of 20. Okay? Then you will see that these durable goods, this Coase conjecture does not always take away the monopoly power. Because what happens then? if we have a low value consumer which has a willingness to pay of 20, then in the second period, if you sell both or if you serve both consumer, you get just 2 times 20. So if the high value consumer didn't buy in the first period, you still would sell it at a price of 50 in the second period, okay? Because 50 is larger than 2 times 40, okay? But if you know as a high value consumer, that if you wait, you don't get it cheaper, why should you wait? Okay? So you don't wait, you buy it at 50 in the first period. Actually, you buy it not at 50, but you buy it at 50 plus times 1 plus R. Okay? You buy it in the first period, you get a willingness to pay of 0. And what's about the low value consumer? Does he or she buy? No, because the price in the first period is not 1 plus R times 20, but it's 1 plus R times 50. You see, the low value consumer doesn't get the product in the first period. And that's, of course, an efficiency loss because this device is lying around in some inventory, but the consumer doesn't get it because the firm, Apple, does intertemporally price discriminate. Okay? So here you see the high value consumer has no incentive to wait, and the monopolist can extract here all the consumer surplus. Of course, that's a specific example because we have only 2 types. If we have infinitely many types, typically you cannot extract all consumer surplus, but you see you can intertemporally price discriminate here. Okay? Now, again, you see we have inefficiency as 1 unit is not sold in the first period. That's what I tried to explain to you. And as a monopolist still owns 2 units of a valuable good. Now, what you see here, again, this is the similar problem as we previously had. If we have 2 high-value consumers, we don't have a problem because both units would be sold from the very beginning in the first period and no deadweight loss would occur. Okay? So it's not always that this kind of durability reduces market power, but it might reduce market power. And the question is, if you're in this world where our willingness to pay, our high value, our lower value consumer has a willingness to pay of 30, what happens? Could you do anything? So Apple won't like it that they have to sell the iPad at a low price in the first period in order to induce a high value consumers to buy it right from the start. Okay, so you don't like that. So what will you do? What do you want to do in this case? So what I want to do is right now just to have a general discussion of the solutions of this durability problem and of the cost conjecture we have here. So what does Apple do? Actually, what did they do with the iPad? That was a really interesting story. What did they do? It turned out that demand was much lower than they expected. They served it as they sold it at a very high price in the very beginning, and it turned out no one wanted to buy it, only a few people. And then after, I think, only 6 months, they reduced the price. Of course, that annoyed the early buyers. They had to pay, I guess, $200 or $300 more for their copy, so they didn't like it. So what actually Apple did is they refunded part of this difference in the price. And this is rather interesting, a rather interesting strategy, because if you tell that you make a refund, I just was confused because I read a note in the slide, okay, in the chat, in the WebEx chat. Okay, so the point is, if you make your customers believe that you won't reduce the price, you don't have to reduce the price. Okay, that's your point here. That's what you try. Of course, other examples are leasing. What you see, for instance, with textbooks and with ebooks. With ebooks are only leased or rented out for a single semester typically. Okay, you don't buy it, you don't get the right to sell it on, because what is rather interesting, textbooks are textbooks for students are a very important market, in particular in the US, where textbooks are much more expensive than in Germany. But the problem for the authors and the publishers is that these textbooks are durable goods. They just don't, you can use them for more than 1 year. And what you have there is a rather active used textbooks market, okay? All of the students sell on their textbooks, but that's of course something neither the publishers nor the authors like, because they sell only 1 unit, and this is used then by generations of students. Okay, what are you doing? You do what economists call planned obsolescence. Okay. You somehow make sure that this product breaks down after a certain time. And how do you do that with textbooks? You just bring out a new edition. Okay, that's why all these US textbooks have a new edition at most every 3 years. Because then, with slight changes and so on, but then the future generations of students have to buy new books. I think that's... And planned obsolescence, of course, is also obsolescence. Okay, that's what you also, or at least is discussed with respect to washing machine. Do firm or use or build in parts where they are sure they break down after 5 years, so that you have to buy a new washing machine after 5 years and cannot use it for 25 years. Okay? Yeah, that's actually what I wanted to tell you here. With respect to this durability or durable goods problem and the cost conjecture. Okay, so this is now all I wanted to tell you in terms of competition and monopoly, in terms of this benchmark. I think we have a few minutes late, and as I always... Now iPads are marketed as laptop replacement with keyboard gadget. A note in a WebEx talk. Yeah, so they try to go up market in a sense, I guess. But I don't know whether this has anything got to do with planned obsolescence, or whether it gets closer to the Microsoft Surface. That will be an interesting thing to observe. Okay, I move on to technology and cost. Only very briefly, I only want to give you the introduction. Okay, and this is also another reminder in terms of, or a refresher in terms of some contents you already have hopefully studied in your undergraduate study. You will see technology and cost and industry structure. We already discussed this point about minimum efficient scale, and just I want to give you a very brief view into actually that's production and cost technology. Okay, the neoclassical view of the firm. So what we are doing is here we just look into profit maximizing. So we have a very simple view of the firm. That's what I already told you. A firm just uses inputs in order to produce some output. And our firm here is just a black box. We don't look into the interior of a firm. Okay, a firm transforms inputs into outputs, and how that works is described by the production function. In yesterday's introductory section, I told you about transaction cost, about Coase, about Williamson, and about some agency problem which might happen inside a firm where it's hard to provide the right kind of incentives so that the manager does or makes decisions which are really good from the viewpoint of the owners of the firm, of the shareholders. Okay, so how our firm structured, that was this discussion about what are the boundaries of the firms. Will I make a certain part for my cars on my own, or will I use a supplier for that? What determines firm size, and so on, apart from production technology, but in terms of the boundaries of the firm, and so on. And how are individuals organized and motivated? That's what we did. And I think I gave you all the respective references already yesterday. So we have a much simpler view of the firm here. And because we just simply assume that it's profit maximizing. And if it's profit maximizing, our simple product firm just or we start here with a single product firm, we just assume that we have some production function, which is the constraint of the firm because it just describes the firm's technology. And here we look into how inputs are transformed into outputs. If we have a single output, which is called Q, and if we have n different inputs, x1 to xn, so capital, labor, electricity, some raw material, and so on, okay, we get some functional relation which tells us if I put in so many or this and this amount of a quantity of a certain input, what is my output, okay? And if of course, I want to maximize profit, and I can do that in two different ways, which I'm going to present, or probably I will only present you the first one today. If I want to do profit maximization in one stage, I simply maximize profit here, which is revenue. Remember, we have a single product. Oh, I just write here, this would be our revenue minus, and this is nothing else than our cost. Okay, because I don't know, is it written somewhere here? No, because I should add it here. WIs are the factor prices. Okay, factor price of factor I here. I. Okay, this is a factor price. Okay, and so what you do is you maximize profit, which is revenue, price times output minus cost, and cost is simply labor cost times price of labor, which would be the wage, plus capital cost plus price of capital, which would be the interest rate or something like that, plus cost for or amount of electricity times price, and so on. You just sum that up. And here, subject to your constraint, which is technology. And if you maximize that, so pi is simply then, you can just substitute that here to get an unconstrained optimization problem. Pi would be simply f times x1, xn, okay, minus some wi xi, I equal I 1 to n. And in order to derive the first order condition, you just take the derivative with respect to some input I, and what you get is p times df, and here you have all these elements, dxi minus wi. And of course, this is the first order condition. This has to be equal to 0, which has to be equal to 0. But this is a famous condition because it simply tells you that the value marginal product here which is, this is nothing else as a marginal product of this factor. So if the factor is labor, it's just a marginal product of labor, and it tells you what if you employ one more unit of labor, by how many units output increases, and we look into the value. That's why we multiply by the price. So this is, in a sense, the value you produce with an additional unit of this input, or with an additional unit of the labor, and in the optimum, this has to be equal to the additional cost, which is simply the factor price. Okay, this is our standard kind of optimality condition. Okay. Oh, it doesn't work. I cannot simply copy it. But the point is, once you have this optimality condition, you can also derive another optimality condition, which I'm going to do in OneNote in the last minute here. I have in OneNote, so our optimality condition was df dxi times price minus, or is equal to wi. Okay, I just put it on the other side. Now, what I can do is, of course, I can use the condition for I and use the condition for j, df dxj, it's wj. Okay, and from these two conditions, by simply dividing it through each other, you get df dxi divided by df, oops, I write it different, df dxj is equal to the factor price ratio, wi wj. Okay, and that's another famous exam or result. This would be called the rate of technical substitution, the ratio of the two marginal products, which is equal to the ratio of the factor price. And that's the condition for optimal factor input. And I think I run out of time anyway. So what I should do is I should stop here. And thank you for participation. Hopefully it was not too confusing, but anyway, you will have the time to ask further questions in WebEx, and also, of course, discuss applications of these sometimes more abstract topics in the tutorial class. Thanks, and see you again next week. Goodbye.